Hi, my name is Ali Kararudi, and in this video I'm talking about insertion sort algorithm in Java. When you use insertion sort, you look at each list element one at a time. If an element is out of order relative to any of the items earlier in their list, you move each earlier item down one position and then insert the tested element. This is very similar to the technique that one would use in order to sort a list of objects manually. Let's take a look at this example. This is the list we're looking at. So if we start from first item, we'll look at the first item. Of course, the first item is always sorted, right? Then we move to the second one, in this case 3. We'll look at the second item and we figure out that second item is out of sort because we have 4 first and 3 after. In this case, we just shift everything to the right and bring 3 to the beginning. So now we have 3, 4. Then we move on, we arrive at 2. We know that 2 should be inserted at the beginning. So we shift everything forward, bring 2 to the beginning. So it's going to be 2, 3, 4. Then we look at the next one, it's 10. The order is correct, so we'll leave it to go. We look at the other one, 12. The order is correct, we'll let it go. We'll look at the next one, it's 1. So what we do is, again, we shift everything, bring 1 to the beginning. Look at this one, it gets a little bit amazing. So 1, 2, 3, 4, and then we jump to 10, 12, and 5. So basically 5 needs to come back. But what we do is we figure out where should we insert 5 in, and therefore we shift the rest on the right side to the right and we bring 5 to the beginning. So that's why the name of this specific algorithm is insertion sort, because we have to find where the item belongs to and then we insert the item right over there. So without any waste of time, let's go to the code this and see how the sort actually works. Okay, here's the code we're going to use for the algorithm of insertion sort. Again, we start with our sum nums like what we did in the bubble sort video, an array of 90, 85, 65, 95, 75, just random numbers. We set 3 control variables, a, b, and temp, and very soon you're going to see how they're used. So a is going to be used in our outer loop, right? So this is the main loop that we do with while, and as long as a is less than the length of the sum num, this loop is going to continue. Okay, next step is to hold on to the second value. Okay, notice this, the initial value for a is 1, right? So when we set temp to be assigned sum num a, we are basically referring to the second element because sum num a is referring to 85, right? Then we have b, which is a minus 1, which means the previous. Remember, a and b are going to be the indexes we're going to use throughout this program. So b is going to be referring to this item. So sum num b that you see is being used here at the beginning is going to be referring to 90. And as you can see, 90 is greater than temp, which is 85, right? So this condition for the second loop is true at the first iteration. If you be sorting in a descending order, you just need to change this to less than temp, of course. Okay, let's go back to our process. So as long as sum num b, which is this element, is greater than temp, which is this element, and b is greater than or equal to 0, which at first, as you see, b equals 1 minus 1, which is going to be what? 1, right? As long as that condition is being met, both of them are being met, then the while loop is going to be entered. And as you can see on the first iteration, this is true, and we're going to enter here. In this case, sum num b plus 1, which literally is going to be sum num a, right, is equal to sum num b. And then we decrease b. See, notice that as soon as we decrease b, b is going to be turning minus 1. Therefore, this condition is false, the entire condition of the loop is false, and we're going to get out of the loop in this case, right? So, if this loop is over or not being met at all, we move to this point, and at that point, sum num b plus 1 is going to be put to the temp, okay, which is 85. So 85 is going to be in the temp now as a b, and then we do a plus plus. So a is going to now be pointing to 65, and we're going to do the same thing, okay? And then I added this loop to the end, which is a simple loop, and we used it in bubble sort 2 just to print out the sorted array, the result, okay? Let's run this program pretty quick. And what I want to do is I want to just pull this up so you see it. As you can see, we successfully ran it, and now we have 65, 75, 85, 90, and 95, okay? So far so good. This is the algorithm that we have. Let's take a look at it again, analyze it even more. I'm trying to make sure you guys really grasp the concept of what's happening over here. So as we said, first a is set to 1, and then the while loop begins. The value of temp is set to sum num1, which is 85, and b is set to 0 because b is greater than or equal to 0. Sum num b, which is number 90, is greater than temp. The inner loop is entered. Remember, as I said, if you were performing a descending sort, then you would ask whether sum num b was less than temp. Anyway, the value of sum nums 1 becomes 90, and b is decremented, making it -1. So b is no longer greater than or equal to 0, and the inner loop ends. Then sum num 0 is set to temp, which is 85. After these steps, 90 was moved down one position and 85 was inserted in the first position. So the array values are in slightly better order than they were originally. So let me just go here and put them after first iteration. You're going to have 85, you're going to have 90, you're going to have 65, 95, and 75. That's the result of first iteration. As you see, the only thing that we did over here was swapping these two, okay? So far, a little bit better. Now, in the outer loop, a becomes 2 because a gets incremented, right, over here as we discussed. The value of temp now becomes 65, and now b is set to 1. So the value of b is greater than or equal to 0, and sum num b 90 is greater than temp. So the inner loop is entered again. In this case, the value of sum num 2 becomes 90, and b is decremented, making it 0. So the loop executes again. We're not getting out of the loop. So the value of sum num 1 now becomes 85, and b is decremented, making it -1. So the loop ends. The sum num 0 at this point becomes 65. So as you can see, after the second iteration of our loop, the values are going to be 65, 85, 90, 95, and 75, okay? This is going to be the result after this second iteration, okay? So the logic again proceeds to work on the new list that we have, and this time the value of temp becomes 95 and b is set to 2. For the loop to execute, b must be greater than or equal to 0, which it is, and sum num b 90 must be greater than temp, which in this case it is not. So the inner loop in this case does not execute. Therefore, sum num 2 is set to 90, which is already what it was. And in order to look at this, think about it in the other word, no change is made, right? So now a is increased to 4. Now if you're at line 18, a is increased to 4, right? And the logic proceeds again. The value of temp becomes 75, and then b is set to 3. The value of b is greater than or equal to 0, and sum num b in this case is going to be 95, which is greater than temp. So the inner loop is going to be entered again. So the value of sum num 4 becomes 95, and b is decremented, making it 2. So the loop executes again. the value of some num 3 becomes 90, and it is and the b is going to be decremented, making it 2. So the loop executes again, and then still we are going to go through it because the value of some num 3 becomes 90, and b is decremented, making it 1. So the loop executes again, and then again the value of some num 2 this time becomes 85, and b is decremented, making it 0. Some num b is 65, which means no longer greater than temp, which is 75, so the inner loop ends. In the other word, the values 85, 90, and 95 are each moved down one position, but 65 is in the left place. Then some num 1 becomes 75. So if I want to put it down here, let me just go over here and continue writing down what the list is at that point. At this point, we're going to have 65, 75, 85, 90, and 95. So as you can see, when we go through this algorithm, each time the inner loop takes care of the shifting and the outer loops takes care of the traverse. Remember, we explained this algorithm and bubble sort algorithm in the previous video on an array just for simplicity of understanding. But the same algorithms could be applied to any type of objects. You just need to adapt it to that object type, just write the proper code and get it to work. With that being said, this video is over, and thank you for watching.